There are different aspects to chemistry. There is the quantitative side, the side that we use numbers and measurements, which we're going to focus on in this video. There's also the qualitative side, where we make observations to help deduce information and infer concepts, which we'll do later in this semester. Measurements require two pieces. They require a number with the unit. A number, just a number, we don't know what it's being associated with. And that can be a problem when we're trying to determine a measurement. A measurement tells us what we are directly measuring, what that number is associated with. Take the number 13. If I just tell you 13, you may not know what we're associating with it. The age that a person becomes a teenager, a baker's dozen, miles, fish, we don't know. That is why the unit is so important. 13 miles is vastly different than 13 donuts. So we want to make sure that when we're working with measurements, we know the unit that that number is associated with, then we can start to understand what it is we are measuring. There are a set of units that we'll use consistently. There is the international set of units called the SI system or the international system. This is the metric system. It is the system that is used throughout the world consistently. It is based off the power of 10, so 10, 100, 1,000, 10,000, so on and so forth. When we are talking English units, that is miles, feet, inches. We don't really use that in science because it doesn't have it's not accepted worldwide, and it doesn't have this very easy transition between values. What's really nice about the SI system is you have what's called a base unit. The base unit gives us that identifier of what we are measuring. Then that base unit can be changed with a prefix. That prefix tells us the size, how big or how small that base unit is. You need to be able to recognize and use the following units. For length or distance, we use meter. Meter is the base unit symbolized as an M, a lowercase m. So when we're talking centimeters, as on a ruler, we know we're using length. Centi tells us how big of that meter we're using. For volume, we are looking at solids. So solids can be measured by what's called centimeters cubed. It's taking in, we're gonna push my artistic skills here for a minute. Oh, goodness gracious. Okay, it's where we take the length, base, height, and find that volume, and we can measure all those by centimeters cubed. When you look up the density of a lot of our substances, they will be measured in centimeters cubed for that reason. Liquid and gas will be measured in liters. Liters has a capital L, and then we go from there. Mass is in grams. Seconds is S. Sometimes you'll see it SEC. Temperature has two different SI units for two different purposes, which we'll talk about in a later video. Kelvin is a capital K. Celsius has that degree sign with the Celsius. You need to know when to use and how to use each of these units. We have that base unit, which we just talked about, depending on what it is we're wanting to measure. Here we have the list of metric prefixes. These provide us the place value that our measurement resides in. Starting with our base, so that grams, meters, liters, seconds, that is the place value of 1. We can go above 1, we can go less than 1. I did not say negative number, but just smaller than 1. You will need to know and have memorized kilo. So kilo is 3 times bigger than our base unit. It's in the thousands place. if we do our place values, so if this is our ones, oopsies. So if this is our ones, here we have our 10, 100, 1,000. We don't really measure in the, we sometimes measure in the tens. Those are your decas, and then we have our hectas, but these are typically, kilo is the major one. Going below, we have our deci, centi, milli, micro, nano, pico. Really, we focus on through micro. Those tend to be the bases we use. We don't use deci too often. So really, kilo, your base, centi, milli, micro. What these negative numbers represent is that the value is less than 1. So we start to put this THS. So if we have the ones place, then we have the tenths, the hundredths, the thousandths, so on and so forth, as we move down that lane. So if you can do your place value chart, you can then start to place the prefixes based off where your number resides. Here's a simple chart a lot of students like to use to help understand metric conversions. This does have a mnemonic called King Henry died by drinking chocolate milk, and we do have that micro down here we use sometimes as well. What's nice and easy to use about this chart is it helps us transition between metric conversions. If I have, let's say, 5 grams. How many centigrams is that going to be? Well, what's beautiful about this chart is it will show us which way to move our decimal. So our decimal always goes past that ones spot. It's what separates the base unit with what goes above ones place and what goes behind the ones place. With this, each time we move to a new box, we move the decimal. And this is that base of 10. We move it by a full position, which is that base. So if I want to go to centi, I have to go 1, 2. So I'm going to move my decimal 2 times. 1, 2. And I'm going to occupy those empty regions with zeros. So there are 500 centigrams and 5 grams. When we are looking at that base unit, all of our numbers that fall behind or to the right of it are going to be larger than that base unit because there's more of them in it. Any number above that base unit, that number is actually going to be smaller because it takes more base units to occupy those larger place values. If I have 15 meters, how many kilometers is that? First, put your decimal at that base unit where the ones place is occupied. Looking at our chart, we're going to go from our base unit up to kilo. 1, 2, 3. We've moved it 3 times. So I'm going to go in the same direction. 1, 2, 3. Put the decimal, and any empty dip is going to have a 0. So we're going to have 0.15 kilometers in 15 meters. So that you can move the decimal as appropriate to go from the different prefixes of the same metric unit.